Okay, so today we're going to look at modulus functions, okay? And modulus functions are always denoted by these two lines here. So how would you say this? You would say that is the modulus of x, okay? And what does modulus mean? It just means the absolute value of the number, or what is inside the two funny brackets, but the straight line brackets. And basically, if you've got a positive thing inside this modulus symbol, then the answer stays the same. If you've got a negative number, you just make it a positive value. So I'll give you a couple of examples. If I said, what's the modulus of 3? It would just be 3. If I said, what's the modulus of minus 5? That is going to be 5. If I said, what's the module of 107? That's just 107, whereas the modulus of minus 1050 is just 1050. So all you can see is, if it's a positive value, it just stays the same. If it's a negative value, it just becomes the same value, but a positive version of itself. Okay, and they actually are quite useful things to use. So what we tend to do though is we tend to solve equations with modulus in them, or we tend to sketch modulus functions. So if I wanted to sketch y equals the modulus of x, well, if I think about the graph of y equals x first, it's just a straight line, a gradient of 1 going through the origin. So y equals x looks like that. Now up here, my y value is positive, my y value is positive, my y value is positive. So in this region, that's absolutely fine because the y is positive. But remember, the modulus turns negative numbers into positive values. So if I wanted to then sketch y equals the modulus of x, this is exactly the same when the y is positive. But when the y is negative, the y gets turned into a positive value, and so you end up getting a reflection. So the purple line is y is the modulus of x. So they might say, sketch y equals the modulus of 2x plus 3. And what I tend to do with this sort of thing is, I always sketch first with a dotted line y equals 2x plus 3. Okay, well, I know 2x plus 3 crosses the y-axis at 3. It crosses the x-axis, well, I'd say 2x plus 3 equals 0. So x is going to be minus 3 over 2. So it's going to cross at minus 3 over 2. And if I were to draw it, I'll draw it with a dotted line, because that's how I do it. I just draw a quick dotted line. And that is the line y equals 2x plus 3. But I don't want that. I want y equals the modulus of 2x plus 3. Now, it's exactly the same when the line is above the x-axis, because the y values are positive. But down below the x-axis, when your y values are negative, they get turned into positive values, and so it just gets reflected in the x-axis. Everything has to stay above the x-axis because the y's always have to be positive numbers. Okay. Now, sometimes this is more common type of exam question. You might say, sketch on the same graph these two lines. Okay, so we'll do the first one. So I'll do this in red. Now, again, what I tend to do first is 2 minus x. Well, negative gradient, it crosses the y-axis at 2. It's got a gradient of minus 1, so it crosses the x-axis at 2 as well. So if I were to draw that as a straight line, it would just look like that. But I want the modulus, so my modulus is going to be at the point when you hit the x-axis, it gets reflected back up again. So that becomes y equals the modulus of 2 minus x. Then it says, do the line y equals 3x. Now that's going to cross at the x-axis, at the origin, because when x equals 0, y equals 0. And the only thing I've got to consider is it going to be steeper or shallower than the line I've already drawn? And because this line has got a gradient of -1, y equals 3x has got a gradient of 3, so it's going to be a steeper line. So I'll just want to draw it in a steeper way. It doesn't matter about the scale, it just has to be steeper. And from this, if the question said how many points of intersection are there between these two lines, well, I can clearly see there's only one, because this line is steeper, so this line here is never going to intersect with that line there, okay? Because the y equals 3x is a steeper line. So there's only 1 point of intersection. Okay, that's not always the case. So let's have a look at a different one. So again, on the same graph sketch, y equals 2x, the modulus of 2x minus 1 and y equals x plus 2. Let's deal with the first one. So I've got to think, what does y equals 2x minus 1 look like? Crosses the y-axis at -1. It crosses the x-axis. Well, 2x minus 1 equals 0, because remember on the x-axis y equals 0, so x is a half. So if I were to draw that, have a gradient of 2, so it's going to look something like that, where it's crossing at a half. But I want the modulus, so it's fine while it's above the y-axis, x-axis, sorry, but then when it's below the x-axis, it has to be reflected. So now I can say where it crosses the y-axis, it's going to cross it at +1 rather than -1. Right, the second line, y equals x plus 2. Well, this one, is going to cross the y-axis at 2, is going to have a gradient of 1. Now, the only thing I have to think is that steeper or more shallow than my modulus gradient? Well, this modulus gradient has got a gradient, of 2. So a gradient of 1 is more shallow. So I need to draw a shallower line. So in this case, it's going to go a bit like that. And actually, if I worked out where it crossed the x-axis, it crosses at -2. Because on the x-axis y equals 0, so you have 0 equals x plus 2, so x equals -2. And so I get a picture like this. So in this case, how many points of intersection are there? Well, there's actually 1, 2. So in this case, there's 2 points of intersection. Okay. Now, sometimes you might get you to draw 2 moduluses on the same graph. So here we go, let's do the first one. So we've got x equals 2x plus 3. Let's think about what y equals 2x plus 3 looks like. It's going to cross at 3. If I make 2x plus 3 equal to 0, it's going to hit the x-axis at -3/2. So my modulus line is okay when it's positive. The actual line y equals 2x plus 3 would come down here. But because it's the modulus at 1, it gets rebounded. Now look at the next one, y equals x minus 1. Right, this would have crossed at -1, and the line y equals x minus 1 again is going to cross at 1, so it's going to look something like this. Now again, is it steeper or shallower? Well, actually I've drawn that too steep, because it should be shallower than the previous line that we've done, because the red line has got a gradient of 2, the purple line is going to have a gradient of 1, so it needs to be shallower. So it needs to look like this, because it's going to have a shallower gradient. So how many points of intersection is it going to have? 1, 2, so there's going to be 2 points of intersection. And the last one, before I get you to do a couple, on the same graph, draw y equals the modulus of 3x plus 2 and y equals 2x minus 5. Let's do the modulus graph first. So let's think about what y equals 3x plus 2 looks like without the modulus to begin with. It's going to cross at 2. Where's it going to cross the x-axis? Well, that's going to be at minus 2/3. So again, the line would look like this. I want the modulus, so it gets reflected and looks like that. Now then, let's look at the purple line, y equals 2x minus 5. So it's going to cross at minus 5. Where's it going to cross the x-axis? Well, the x-axis, on the x-axis y equals 0, so you have 0 equals 2x minus 5. So it's going to be when x is 5/2, which is there, 5/2. And again, is it steeper or shallower than the red line? Well, it's shallower. So it can't, I've got to draw my gradient shallower than the one on there. So actually I need to draw it a bit more like that, sorry, with the 5/2 over there, because I need to draw my line more shallow. So actually this equation has got no points of intersection. Okay, right, here we go. On the same graph, sketch each of the two lines and state how many points of intersection there are. I want you to have a go at this. Have a go, press pause, and when you press play again, I'll show you the answers. Okay, so first one, think about what 3x minus 2 looks like. It's going to cross at minus 2, cross the y-axis at minus 2, cross the x-axis at 2/3. So we need to reflect the negative part above the x-axis. Y equals 2x is not as steep, so it needs to be drawn as a shallower line than the red line, and so there's 2 points of intersection. Okay, here we go, got two modulus curves to draw. So again, think about what y equals 6 minus x is going to look like. It's going to cross at y equals 6 and x equals 6 for the two axes. Okay, but again it gets reflected. What does 2x minus 1 look like? Well, it's going to cross the y-axis at minus 1 and the x-axis at 1/2. It's going to be steeper than the red line, so you need to draw it steeper. And so again, there's 2 points of intersection. Okay, so we had y equals modulus of x minus 3. So y equals x minus 3 is a gradient of minus 1. It's going to cross the y and the x-axis at 3. But again, because we're drawing the modulus, it gets reflected above the x-axis. And then y equals 2x minus 2 crosses the y-axis at minus 2, the x-axis at 1. And again, you've got to think steeper or shallower. Well, it's going to be steeper because it's got a bigger gradient. So in this case, what you notice is, if I just get my highlighter, this is going steeper than this line, so they are never gonna meet once it's gone past this initial intersection point. So for these two equations, there's only 1 point of intersection. Okay, and the final one, thought I'd give you an example of them all. You had y equals x minus 5, the red line, so that's going to cross the y-axis at minus 5 and the x-axis at plus 5. And then you've got y equals the modulus of 2x plus 3. It's a steeper gradient than the red line, so these two are never going to meet. Okay, right, we can also use modulus with quadratics. So let's think about exactly like we've done before. The first thing I actually think about is, well, how would I draw the line y equals x squared plus 3x plus 2? Well, I'd want to find where it crosses each of the axes points. So, factorise. So I'll get x plus 1 and x plus 2 and make that equal to 0. So I know it's going to cross at x equals minus 1 and x equals minus 2. I also know it's going to cross the y-axis at 2. So with my red pen, I'm going to draw y equals x squared plus 3x plus 2. So it's going to cross at minus 1 and minus 2. Sorry, I'm just going to move this line over a little bit. So here's my nice quadratic crossing at minus 1 and minus 2. But if I want y is the modulus of x squared plus 3x plus 2, I cannot have anything below the x-axis because I can't have any negative y values. So wherever the line is above the x-axis, it's exactly the same for the modulus. Okay, and I can see it crosses the y-axis at 2. But when it's below, we have to reflect. So what you actually end up with, and I'm going to take the red line away, is something that looks like that. Okay, so I'll put the red line in, but dot it in, because that's what I tend to do. I tend to dot the red line in first, just the function without the modulus, and then I draw it with reflecting anything below the x-axis above the x-axis. So again, you can have the same situation where we're going to work out how many points of intersection there are between two graphs. So let's look at our modulus. Y equals x squared plus 2x minus 24 first. So again, need to find where it crosses the axes, where it's going to cross at minus 24, because that's where it crosses the y-axis. Factorise it to find where it crosses the x-axis. So I need two numbers to multiply to make minus 24, add to make 2. So it's going to be 6 and 4. It's going to be minus 4 and plus 6. So x is minus 6 or x equals 4. So with my dotted line, it's going to cross at minus 6 and 4. And I'm going to try and... I'm never very good at drawing these on these iPads, but my quadratic would look something like that. So if I want the modulus of that function, wherever it's above the x-axis, it is okay, it stays the same because y is positive there, but wherever it's below, it has to get reflected. So it crosses the y-axis at plus 24. Okay, and then you've got a simple purple line of y equals x, so that's just going to look something like that. Okay, drawing it quite shallow because obviously the scale on the x-axis is not the same as the scale on the y-axis, which is why I haven't done an exact diagonal line. Okay, how many points of intersection are there? There are 1, 2, so it's 2 points of intersection. Okay, got 2 more examples like this. So again, y equals x squared minus 3x minus 10, but there's a modulus around that. First of all, I'll think about what y equals x squared minus 3x minus 10 looks like. It's going to cross the y-axis at minus 10. The x-axis, I need to factorise it. So I've got 5 and 2. I'm going to have minus 5 and plus 2 equals 0. So x equals 5 and x equals minus 2. So my curve is going to look something like that, where it's crossing at 5 and it's crossing at minus 2. But if I want to do the modulus, while it's above the x-axis, it's good. But when it's below, it has to get reflected. So it looks something like that. Okay. And then if I do y equals x plus 5, well, that's going to cross the y-axis at 5 and it's going to cross the x-axis at minus 5. Okay, so you can see, because the scale's not the same on the y and the x, it does end up being quite distorted, or at least it doesn't look like it's a y equals x function. It doesn't look like it's a gradient of 1, but that's just because we've got the different scales. So how many points of intersection does this one have? Well, it's actually got 1, 2, 3, 4 points of intersection. And the final one for us to have a little quick look at, y equals the modulus of x squared plus 2x minus 3. So let's go back to just thinking about x squared plus 2x minus 3. It's going to cross at minus 3. Let's think where it crosses the x-axis. So we've got to factorise it. So it's going to be a 3 and a 1. It's going to be a plus 3 and a minus 1. So it's going to cross at x equals 1 or x equals minus 3. So x equals 1, x equals minus 3. It's going to look something like that. Sorry, I'm going to change where... I should always draw my lines in first and then put it on the x-axis and the y-axis. It's always easier. So again, above it's fine, but we have to reflect everything in the x-axis. So again, that's crossing at 3, that's at 1, and that's at -3 on the x-axis. And then when I draw y equals x plus 3, well, that crosses again at 3. It's got a gradient of 1. It's going to cross the y-axis at -3 and the x-axis at -3. So this line is going to look like this. So it's not that common, but occasionally you'll get a question like this, and it's actually got 1, 2, 3 points of intersection because it's just touched at a corner. Sometimes there's another case as well when you can get this, but these don't tend to come up because people don't draw accurately enough. But you can have the situation where you get 3 points of intersection when you do this, and you end up with it just touching the curved part. So you can end up with 3 points, 1, 2, 3, like that as well. Okay, so final bit, 3 for you to have a go at. Sketch both the quadratic, the modulus quadratic, and the line, and let's find out how many points of intersection we have for each of these as well. Press pause, have a go, and press play when we're finished. Okay, so modulus of x squared minus 4x. Got to think about what x squared minus 4x looks like first. Well, it crosses at x equals 0 and x equals 4. So our modulus curve looks like the red line. Then you've got y equals 2x. Now make sure you extend that 2x long enough. Eventually, if I just look at this region up here, okay, eventually that quadratic is going to be increasing very quickly, so that y equals 2x is going to cross up here as well. Okay, so just don't forget that sometimes. So you end up with 1, 2, 3 points of intersection. Right, next one. So again, y equals the modulus of x squared minus x minus 12. Think about what that quadratic would look like. Reflect anything below the x-axis, above the x-axis. Then you've got y equals x minus 1. And in this case, there's only 2 points of intersection. And the final one, we've got the modulus of x squared plus 2x minus 15. Think about what that quadratic would look like without the modulus. Reflect anything above the x-axis. Okay, now be careful with this because sometimes this isn't obvious, but y equals x plus 6, the line y equals x plus 6 is going to cross the y-axis at 6, but it's going to cross the x-axis at -6. So it has to start further to the left than where the quadratic touches the x-axis. And that means you've got the obvious 2 points of intersection here, but it's not quite obvious down here, but there are 2 separate points of intersection down there. So there's 4 points of intersection for this one. Okay, hopefully that's all right. If you need any help, get in contact with me and have a go at the worksheets.